Hello and welcome to Module 3. In Module 3 we're going to start off looking at what an integrated development environment is and how you use it. We're going to look at conditional statements in pseudocode. We're going to look at how you can use comparison operators in your conditional statements. We're going to look at how to write code that will repeatedly perform actions in the form of a loop. We're going to look at how you can interact with the user by creating a little interactive menu and having that menu show up repeatedly by a loop. We'll also talk about how you can work with a list of values, which is a variable that holds multiple values at one time. We'll look at how you can write data to a file, and we'll also look at how you can inject arguments into your program when it runs. So in the form of these program arguments. Lots of things to cover, so we'll get started now. Our first stop is looking at an integrated development environment. This allows you to program much more quickly and troubleshoot your code more quickly. Really, once you get used to using a well-designed IDE, you really don't want to go back. Now, the one I've chosen for us in our course is extremely popular in the industry. It's called PyCharm. A couple of great things about it. It runs on multiple operating systems. It's very good at what it does. It's pretty easy to learn, although it can be difficult to master because it's got so many features. And finally, it's free. So to get it, you have to go out to the PyCharm website, I should say the JetBrains website, which is the company, and you have to download it. So there's a little download button that you click. You want to get the community edition. There is an education edition available for you as a student, which does have a bunch of extra features and stuff, and you can certainly get that if you want. But I like to use the community edition because it doesn't have as much extra bells and whistles. And as a beginning course, I don't think you need all that. So click on the download button, and it will take a little while because it's about a 1/4 gigabyte, 258 kilobytes of 1,000 kilobytes of file there, and then you just double click and run it. The install doesn't take very long. You can put it anywhere you want. It's not very big. It unpacks about twice at 1/2 gigabyte. 64-bit launcher, if you're using a 64-bit OS, add launcher's directory to the past. Yes, you definitely want to do that. It says restart needed, and I believe that is true. In the context menu, when you right-click things, you can open a folder as a project. That's kind of handy. And certainly I want to associate the PY files that we've been making with this program. So I want to check all those boxes if I'm on a Windows machine. If you're doing it on a Mac, it may be a little bit different, but it'll be similar. And that's pretty much it. You just let it cook. Once it's installed, I'll go through and do the restart if it's necessary, and I believe it will be. And then we'll come right back and look at what the user interface looks like after the installation. Once PyCharm is installed, of course, you've got to go open it. So come over here to JetBrains and find PyCharm. Drag it over here and start it up. Now, since I've had PyCharm installed previously, I've got a configuration file I can point to. But you can always just click on Do Not Import Settings. I'll do that just for our class or the video, which means I'll have to go through and set the settings. Working in a dark background is really great on the eyes. It's much easier to work with, I feel, but it's not great for a class environment. So I'm going to go ahead and set it to light version. And let's see, anything else? I have to say recommend all of you. Nope, not really need that, don't need that, I'm good to go. Now, once it starts up, you'll need to create a project. And in my case, I'm going to create a project in my Python programming class folder. So let me go to the programming class folder. So C drive, Python class, and this is module 3. So I'll make a new folder called Mod 3 Demos. I want to pick an interpreter so that we can run our code. So to do that, we can point to an interpreter. If you already have one, you can choose that. If not, you can make a new one. And what this is going to do is it's going to make a copy of Python based on your installation. So I've installed Python many times. This is one of the installations, but I've got several. I've got one right off of C drive. You can see I got 3.7 and 2.7 and 3.7.2, etc. You just pick whichever installation you want. Hey, it looks like I got another one down there too. And then say create. And what it's going to do is it's going to copy over files from your Python directory so that you can have a virtual environment. That way, if you want to change things or whatever, it will be separate from the Python install you have. It's kind of a fancy way to protect the Python install. Let's see, Windows Defender might be impacting my build performance. I really don't care. Thank you. And now we have a folder. Now, there's a bunch of things I want to set up. And if I want to, I go up to File, I go to Settings, and a really great feature in here is this little search window. So I want to change the fonts. So I type in fonts, and it will bring me to a spot where I can choose a particular font. Like I want to bump it up to a larger size for presentation. Let's see. There's a bunch of things I can do. Change font size when I hold down the control button and the mouse wheel, use the mouse wheel. I definitely want that for the course. And there's actually just a ton of settings, but that's the way you find them. So if there's something you want to change, it's an easy way to do it. So for example, maybe I want to come over here and change some of the options in the menu. I can do that, like run. And it'll show me where the word run shows up in different places, and I can make changes accordingly. Now, there's a lot of settings that you can do. Like I said, this program is easy to use, but can be difficult to master because there are so many settings. But to just use it for our course, it's going to be quite easy. What you do is you click on the folder and you tell it that you want to make a new Python file by using the context menu. And then once you've done that, you choose that you want to make a Python file. I'm going to call the first one test.py. If you don't put the py extension on there, as long as you've chosen that it's a Python file, it'll put the py file extension on there for you. And then you can test that it's going to work by typing in some code and then running it. You just right click on the background and run it. You should see the result down here. Now, in my mind, that result is a little bit small for a course, so I'll go through and change that. And up here, I want to change this too. It looks like for some reason the control mouse wheel isn't working, so my guess is that I need to restart it. Now, because I want to restart this, I want to make sure I save my program. To tell you the truth, it should already be saved. It's automatic. So I'll just go ahead and say exit. I'll come back into PyCharm. And we'll see if that feature has been set. It should load the last, I don't need to see these tips. It should load the last file that project we were working on. And it does. I'm still not seeing that option, so I'll come back over here and say settings. And it must be that I changed something or didn't do something like hit the OK button. Check that. Let's see, I want to use the custom font. Apply. Much better. So now I'll run it again. Oops. And down here, I should be able to zoom in. That's lovely. Okay, we're ready to go. So that's how you get started. And for now, that's all you really need to know how to do. Now remember that this file is going to be in a folder. So like when you do your assignment, you probably want to make a folder, make a new project, so a new project, and give it a name like assignment. This will be assignment 3, of course, for this module. And would you like to create a, I've already got a folder called that, so let's say I did, and I just say sure. If you say this window, this project will close and open up, it'll open up the new. If you say new window, you can have both side by side. You can see I've got some code in here, or file in there for the assignment. Nothing in there yet, but I've got the file ready to rumble. So that's how you would use PyCharm. And again, now the thing to do is just start using it. And we'll move on to the next topic. When you start writing programs, especially complex programs, a good place to make that start is by writing out your intent. And we often do this in programming using something called pseudocode. So pseudocode is not actually all programming code. It's not going to perform any actions. It's really just a note to yourself. And the idea is that you type out the note and then you come back and you fill in the code to perform the actions defined in your note. So for example, let's say I start off with two little notes, get user data and print user data. Those are the two actions I want to perform. After I type those out, I think about how I'm going to do that, and then I would start writing code to perform those actions. So first one is to get user data using an input command. The second one is to display or print user data using a print command. And so I might end up with code that looks like this. Now do keep in mind that pseudocode is different than just a comment. A comment can be something like this, where it just says, use input to keep a console window from closing. That's not really pseudocode. It's just some code that might be useful, or an example of what might be useful for a future user. I like doing this, adding this in, because if somebody looks at it later on, they can just quickly uncomment that and use that feature, or maybe they can just use that tip for working with the code at a later point in time. Pseudocode is actually laying things out, actions out that you're going to perform in a particular order. So performing particular actions in a particular order is known as an algorithm. So you're laying that out ahead of time and then putting in the code. But keep in mind that adding comments in is also a real good idea to support your code and support your application that you're building, especially if you're going to have other people work with your code, including you in the future. Let's look at an example of some pseudocode and talk about conditional logic, or conditional statements. So the classic conditional statement is a if-else statement block. And what it does is it evaluates an expression asking the question if something is true, and if it is, perform some kind of action. The next part, the else part, says if it's not true, perform a different action. So here's an example of some pseudocode that kind of lays out the process. Now it's pseudocode because this code is not something that is expected to run. It just lays out the general pattern. If it's true that a condition is equal to true, then perform some kind of statement, but only perform these statements, one or more statements, if the condition is true. So if it is that true, that condition 1 is equal to true, you're good. Go ahead and perform that next action. Otherwise, or else, perform a different action if it's not true. So this is an example that lays out the purpose and the general pattern, the steps of actions in a particular order that are going to occur when you write a conditional statement. Now in Python, that looks like this. You've got a variable, and the variable is going to be set to the value of 1. Next, I'm going to ask the question, is it true that that variable is equal to the value of 1? Then, if that is true, I'm going to print out 1. Otherwise, I'll print out something other. And by taking that code, I'll copy that code, and I'll come over to PyCharm. I'll paste that in. Not get a copy. Let me try this again. Copy. Highlight. Gotta click on the right thing. Paste. I can then go ahead and run it. Now, you'll notice that PyCharm has underlined a few things for me. These are things that might help my program to look a little bit nicer. Sometimes I agree with them and sometimes I don't. For example, they say that in Python, you can remove the parentheses. You don't need the parentheses to perform that action. I don't particularly believe that is a good choice. I think that using the parentheses to indicate the conditional statement is a good choice, but certainly it's a recommendation. Another one here says the indentation is not a multiple of 4. So what they want is 4 spaces. And if you decrease it and then hit enter, it'll fix that for you. Now, again, you can do however many spaces you want. But as it says here, the PEP8 version indicates that you want 4. If you agree with that, great. Put it at 4. If not, you just make your choice. Another one it states is that at least 2 spaces before an inline comment. Okay, somebody thought this would be a good idea. Also, they would like you to have a space after the hash mark. Okay, and let's see, anything else here? Oh, now this is something that is true. If you've got 4 spaces up here and you've got 2 spaces down here, that's going to cause me a problem. So I'm surprised it didn't. So I guess I lied to you. But I tell you what, it's not a good choice. So make sure that if you put in 4 or 2 or whatever it is, make sure it's consistent. That is a very good choice. And there we have it. The code is actually working as expected. If we change this to something like 10 and try it again, we should expect it to print out other, and it does. That is a conditional statement. Now, a couple of things to note. When I use a conditional statement, notice that I'm using the single equal signs to assign a value and the double equal signs to examine or evaluate the expression as is the value in integer var equal to 1. So this is the equity operator. Is it equal to each other? Double equal signs. In other languages, they use a single equal sign for both. And the context is what decides whether or not it's going to be an assignment operator or an equity operator. But in this language, and many other ones, it uses a double equal sign to do that. Now, after that expression is evaluated, it can run 1 or more statements, as I said. So in this case, it would run both statements. It wouldn't just run the one. And if you only have one statement, you can just go ahead and put it on the same line as the if statement. Now, I got to tell you, the PEP standard doesn't like this. But to tell you the truth, it's very convenient in collapsing the code, so I will often use it in our course. And other languages, it's perfectly acceptable. Remember that the PEP standard is not really a standard, it's a recommendation. It's not a bad one to kind of adhere to, but you should know when you can bend the rules after you get, programming. Consistency is the key. So I will be using this syntax throughout the course where on the same line, if I only have a single statement on the same line, I'll put it on the same line as the conditional if, and also on the else. It's just a convenience way of doing that. Another important statement is the if-else-if statement in Python. Now, this is similar to most other languages' switch case or select case statement. Python doesn't really have a switch case or select case statement, but the if, else, if is really close. So the standard pseudocode, that would the general pattern that you would look for in a switch case statement, looks like this: switch or select some kind of expression, and then you evaluate that expression and then check to see whether or not you have a match. So let's say I had, is it true that, or what is the value of 5 plus 2? Well, that's 7. So if the case 7 was put here, it would actually perform that code. If it wasn't there, it would look at the next case and look to see if there's a 7 there. And if it finds it, it performs that code. If not, it goes down and possibly performs some default code. So the pattern of a switch case statement is check an expression and then find a matching value. If you find a matching value, perform that particular block of code. Very, very handy to use in programming. Now, once again, we don't have that in Python, but we have something similar in this if else if statement. It looks like this. So if something is true, perform an action. But if that's not true, how about this one? Check this one, see if this one's true. And you can have as many of these as you want. So I can have 15 possible cases to examine. The first case that it finds to be true, it will run that and skip over all the other code. What I mean by that is this. If I run it like this, it shows 2. And it's because it went and looked at the first line and set the value to 2. It looked at the second line and examined, is it true that integer var is equal to 1? Well, that's not true. So it skipped over line 3 and went down to examine the next possible case. And that case is the question, is it true that integer var is equal to 2? Well, that is true, and as such it prints out the value of 2. If I set this to 1, it will never get down to line 4 and line 5 or anything else, because as soon as it finds a matching answer, it performs the action and can just exits out of that block of code, the if else if statement. It doesn't go any further. If I put some kind of statement down here, we can see that it does indeed skip over all the other code. And if I put in something else, something that doesn't match the first condition, the second condition, it'll just use the default. And of course, still go down to bottom. Now, in that pseudocode that we were just looking at, it does the same thing, but in these, most languages, not all, you have to actually tell it to break out. So if you find a match, don't go any further. You indicate you don't want to go any further by putting the word break in there. That is true of things like C, C#, Java, etc. A number of languages have this feature. It's very similar to the if, else if that you use in Python, and it's a good one to know about just in programming in general. But in that case, you have to manually break out. Some things like the Transx SQL language, you don't have to manually break out. It does the same thing as the Python if, else if. As soon as it finds the first match, it's out of there. It doesn't go any further. So it really depends on the language. And this is a powerful option to use. Once again, in Python, we use it like this. The if, else if, and notice the spelling, and then the next condition. Speaking of conditions, you can have multiple conditions in an if statement. So if it's true that the variable integer var is 1, and it's true that string name is Bob, if both of those are true, because I'm using the and keyword, then print out 1 and Bob. Otherwise, print out other. Well, both those are true, so it would print out 1 and Bob. On the other hand, if I come down here and change the value to 2 in Bob and ask the same question, that will no longer print that out, or will it? Actually, it will. And the reason is because I've changed it from and to or. When it's or, only one of these has to be true in order for it to result in a completely true statement. When it's and, both of them have to be true. Both conditions or predicates have to be true before you have a completely true conclusion. So this expression has to be true. This expression has to be true. If both of them are true, the whole thing is true, and you get print 1 in Bob. In this case, only one has to be true, so that one is not true. That's a false. This one is true, but since only one has to be true, it's either or. In that case, you do not have, it's sufficient to be evaluated as a true statement, and it would print out 1 in Bob. Do be aware that in other languages we have something called XOR. XOR is the exclusive or, which this means it has to be one or the other. So if it's both are not true, that's not going to work. If both are true, that's not going to work. One has to be true and the other one not, with the XOR. With the OR, if both are true, that's no problem. As long as one or more are true, then it will result in a true condition. It'll print out the action for the true. You can take an if statement and put it inside of another if statement. When you do so, this is known as a nested if. So here's an example of that. I say, if it's true that integer var is equal to 1, it is. Then print out 1. But next I want you to do something else. I want you to examine whether or not it's true that a string name is equal to Bob. Well, since that is true, it would print out Bob. So you'd have two different conditions. One is nested inside the other. This is known as a nested if. And you can nest them over and over and over again. In practice, nesting 2 or 3 levels deep is about all you're going to see in real life. You may see more, but people try to discourage that in programming. If you're going down 3 or 4 or 5 levels deep, then you'll probably find that you can write this code more efficiently. And it becomes confusing. Remember that this is different than the if-else if. And often I can use the if-else if option to perform an action that I want instead of nesting. Still, it comes in handy. Sometimes this is exactly the tool you want to use. So I recommend this module, you play with both. Play with both and see what they do. Make sure you understand how they work. One of the ways to make sure that you understand it is to try a simple lab. Why don't you go ahead and pause the video and type out this following code and then write down what it does and what it doesn't do, and we'll come back and talk to it when you're done. I'll see you in just a few minutes. Okay, for lab 3, you should go over here, right click on the project icon, make a new Python file, type in lab 3-1, and then type in the code. I'm going to paste in the code because my typing is abysmal and you don't really need to watch that. I think it's painful to watch actually, but we should test this. And the question I have for you, did it do what you would expect it to do? You'll notice that it says up here, the value of integer var is 2. So you might have expected it to print out 2. But you'll notice that this is a nested if. What this means is it would never actually reach that point because it would have to be 1 first. If it was 1 first, then it would print out 1 and after that evaluate whether or not it was equal to 2. Well, if it's 1, it can never be equal to 2, and as such, that'll never print out. If I wanted to evaluate that differently, I would change this to elif. And now it would ask the question, is it 1? Nope. How about 2? Yep. And it would print out differently. So hopefully you wrote that down. Hopefully it made sense how this worked, and we'll move on. So far we've looked at the single comparison operator of a double equal signs, the equity operator. But there are actually several other ones. There are actually 8 operators in total. And they are the less than or equal to, the greater than or equal to, the equal of course, the not equal, this negates the equal, the is and is not. So classic examples would be 5 is less than 10. 10 is less than or equal to 10. 10 is greater than 5. 10 is greater than or equal to 5. 10 is the same as 5 or equal to 5. 10 is not equal to 5. Object X is the same as object Y, and object X is not the same as object Y. Now, in this case, with the is operator, we're comparing to see whether or not the space in memory is the same space in memory for 2 different things. So this is operator verifies whether or not 2 variables are used or pointing to the same memory address. So are 2 variables actually pointing to the same memory address? Remember us talking about the value types and reference types? This is very useful when we're dealing with things that act as reference types. We're asking the question not if the values are equal, but are they pointing to the same address location or not pointing to the same address location. Here's some examples of using a comparison operator with a string. So if I'm looking at Bob, lowercase b, and another one with an uppercase b, that is not equal to each other. When I'm asking for a comparison, it is case sensitive, and that uppercase letter is going to make a difference. An uppercase letter and a lowercase letter are not equivalent to each other in most languages. Now, in some languages, like the SQL language, it may be. There are some languages where that is true. But in general, if you have to make an educated guess, it's best to guess that they are not equal to each other. Now, you can change that behavior by lowering the casing. So if I use this function called lower, when I get it, it'll change all the uppercase letters to lowercase. In this case, Bob with an uppercase B will also be converted to lowercase. And when I ask the same question, is it true that lowercase b in Bob and uppercase B in Bob are the same? Once it's lowered on each side, that prints out as true. That's a very handy technique to know about, especially if you can't control exactly what the user types in. So later on, we're going to be putting a menu together, and we want to make sure that when the user types in a menu choice, like choose A, B, or C, that if we expect it to be uppercase A, B, and C, if they type in lowercase a, b, and c, we want to be able to handle that, or vice versa. If you want to change it from a lowercase to an uppercase, use the command upper. When you want to go the other way, use the command lower. The not operator can be used in a variety of places. You can say, okay, this is true. str var is equal to Bob with an uppercase B. That's going to print out as true. Now I can reverse that. It's still true until I negate it. I change it from true to not true by using the not operator. And now this will print out false. Negating things can often be useful, but it can also be confusing. So you want to avoid that. Still, there's no doubt about it, you will come across code that looks like this. So even if you don't use it very often in your own code, when you have to read other people's code, be aware of it. That's what this does. It converts a true statement into a false. Another way to accomplish that is by using this equal, not equal. So this exclamation mark is known as a bang. That's the slang for it. This is a bang, and it's exclamation mark. So bang equals or not equals. Bob is also going to evaluate as false because it was indeed the same. And it'll print out false. So that's negating. That's a not operator. Comparing different objects. If the objects are acting as a value type, they compare the values. But if objects are acting as reference types, they compare the address location. Now to accomplish that, I'm going to create something called a class. A class is a way of holding a set of variables, constants, and functions. Methods, same thing. I don't want to make it more complex than it has to be. I'm going to make a class called demo. I'm going to put the word pass in there to indicate that I'm going to come back to it at some point and put in the constants and the variables and the functions. That's just the notation that we can use in Python. A lot of other languages don't have this feature, but Python does, so we'll use it. Next, I'm going to make two variables, not of integers and not of strings, integer class or string class. I'm going to make two variables that are a demo class object. And these demo class objects are going to be assumed to be complex because of custom objects that I'm making. And they're going to be examined as a reference type. And we can see that behavior when we ask the question, is it true that D1, object D1 and object D2 are equal to each other? Now, neither one have an actual value in there, but even if I put a value in there of some type, it would not compare the values. When it's used as a reference type, it'll ask the question, are they pointing to the same address location? They are not. These are two different objects in memory. They're not pointing to the same address location, and as such, it'll print out different. So this is a case where we're comparing objects. And again, some objects that you make act as value types. And when they do, the value is compared. Other can act as reference types. And when they do, you compare those, it compares the reference, the address. Another tool that operator you can use with this comparison is the is operator. So the is operator does the same thing. Notice I've got the same setup. I've got a class called demo. And I'm creating two objects, D1 and D2, from the demo class. So I've got two objects in there. And I ask the question, are they the same? Are they the same object? And if it's the same object, it would print out the same. But they're not, so it's going to print out different. And I can also do the same thing down here. And if I go ahead and point object D1 to the same address as object D2, this will change the address location of D1 to the same point as D2. Asking the same question will show that it is the same because I've changed the address that D1 was pointing to. Now let me load this up in PyCharm and play with it for just a minute. First of all, let's make sure it works as I advertised. Always a good idea. So first one, it printed out different, and the next one printed out the same, exactly what I said. So we can see that that works. That's awesome. But let me do another thing. I'm going to change this over to an integer. Now they're the same integer. But if I ask the question, is D1 the same as D2, what do you think the answer is going to be? It says it's the same. So in this case, it's examining it and saying that they are the same value. Now in other languages, this would actually evaluate to false because they're not pointing to the same address. But this is Python, and they try to assume that they know or make educated guesses about what you are intending to do. Again, in other languages, they won't make that assumption, and so whenever you see this operator, always test. But most of the time, though, what you'll find is that it would be different because they are not, although they have the same value, they're not the same object. They're two different integers. Let's go back and look at some more examples. We want to test this. So I'm going to set up some other examples here. This time we're going to look at a string. And I'm going to run this. So the first example, is it true that string name is the same as string nickname? And yes, that's the same. Next, how about the is operator instead of the equity operator. And that is also considered the same. Once again, you can see that the string is acting as a value type comparing the values. Now I'll change this to a list. Remember, a list as a collection of one or more values inside of an object. Now, I probably should have changed the prefix on here because now it's a list object, but just go with it. So if I ask the same question now, if I convert this over to a list, the equal sign is examining the value and saying, yes, they're the same. But notice the is operator has changed. The is operator now says they're different. And that's because for more complex objects, like a list is more complex than a variable that has a single value. For more complex objects, they will typically behave as reference types. And it really depends on who wrote the code as to what it's going to do. So you should always test. In this case, you can see that all that's changed is still a string inside there, but now it's been wrapped up inside of a list, and we see it performs very differently. As you've seen, there's lots of times where we compare whether something is true or not. In most languages, we also use the number 0 to indicate a false value. So this is not true in every language, but almost every language you'll ever come across. Also, the other numbers that are not 0 will be considered to be a true value. To see what I'm talking about, let's look at some code. So here's an example. If I type in, if it's true, that's the Boolean value of true. Notice that it's uppercase T, it'll print out T. And in this case, using uppercase T is a true data type. Let me show you. Oops, I'm in the lab file. I don't want to do that. I want to use my test file. There we go. So this, if I go ahead and do something like this, remember the type function? It'll print out the type as a class Boolean, class bool. So this is evaluating as an object, a true object, and we can just say if something is true. Let's print out the validity of it. What I want you to do now is go ahead and pause the video, try typing out the rest of this code, write down what it does, and then when you get done, go ahead and unpause and let's examine it further. Once again, I start the lab by right-clicking on the project and making a brand new Python file and calling it lab3-2. And then I type in this code and I test it. So we'll run it and see what we got. So using Boolean values, true and false, we see T for true and F for false. Yes, those work as I would expect them to. But now let's go ahead and use numbers. So I use 0 to indicate true or false. In this case, it's false. And again, that should be expected as well. What about the number 1? That is considered true. And what about the number 2? That is also considered true. Now, this one you have to be a little careful on. There are times where you can only use 0 and 1. Anything else will not evaluate correctly. Not in Python, but in other languages. So you do want to be careful about that. Once again, if you are in doubt, you need to test it. That's always the case. So whenever you move to a different language, when you come across something like this, don't just assume that any non-zero value is true unless you test it. But in Python, any non-zero value is indeed true. I guess I have another question. What do you think would happen if I put a -1 in there? Let's find out. So using numbers, I see false, but true again. So even a -1 is still considered true. It's any non-zero value. What about this, the strings? So if I use A, B, and C, what do I get? I get a true statement. What about if I print out just an empty string? That's considered false. Now, an empty string it has the quotes, but there's nothing inside. Nothing inside, so that will print out false. An odd behavior, perhaps, maybe convenient behavior. Let's see, somebody doesn't input anything on an input. You might be able to use it for that. But that's the way it behaves. So you just have to know how a language behaves and then take advantage of that. Let's look at a couple more examples here. This one can be tricky, so I want to just spend a little bit more time on it. So what would happen if I asked the question, is true equal to the number 2? Is that the same? Well, it turns out that even though 2 does evaluate on its own as a true value, any non-zero value does, if you were to try to equate them, that condition would evaluate to false. So it would print out no, even though you might expect it to go the other way. I don't know why. It doesn't really matter all that much, but it does mean that you need to test that. Let's go ahead. Let me go back to my test file here and double check that that's true. Now, as you're going through the course, double check. Take the time to pause and stop and type in the code. Make sure you understand what it does. And let's do something like this. Let's modify it and see what happens if you use 1. Well, look at that. It does. Remember how I said that in many languages you can only use 0 and 1 to evaluate as either a Boolean true or false? Well, in this case, in Python, 1 does evaluate as the same as true, but 2 does not. Well, wait a second. That's only on certain occasions. This means that if you're not paying attention and you're not testing as you go, you could end up with some mysterious bug in your code that would be difficult to troubleshoot. Always do a little bit of work and test. Do a little bit more work and test. Do a little bit more work and test whenever it's possible, because you want to find out odd little features of a language like this early on, so you can make changes to your code as you type. Let's look at some other examples here. So I might do something like this. Let's set it 100 and 100. I'm looking at a test. Is it true that 100 is equal to 100? If that is true, and it would be because it's going to be testing the value, then is it true that 0 is equal to true? Now notice I've got parentheses on there, so it's going to evaluate that first. Let me take this entire block of code and put it over in PyCharm. There we go. And I don't want to run the entire block of code, so what I think I'll do is I will just highlight some of it, and I'm going to comment out some of it. Let's see, the comment is, let's see, where are you? So it's right here under comment with line comment. You can also use control / So if I'm over here and I've highlighted all this code, you can use control / it'll comment it all out. Interesting they use / because in the C cell languages we comment things out like this with double /. So that may be a nod to that. Anyway, so now this code down below will not be ran, and I can isolate this code all by itself and test it. Let's go ahead and do that. And you can see that the 0 test is indeed printing out false. And it's because, again, this ran first. The precedence operators, or the parentheses, is going ahead and evaluate this to true. But now if you ask the question, is true equal to 0? That is not true. Let's go ahead and comment that out. There we go. And I'm going to highlight this next block of code. Do the same thing, control / and that will uncomment the code. And we'll try it again. This time it prints out true. That's because I'm looking at 1. But what happens if you have 2? Once again, we comment this and uncomment this next block. Try it again. False. Because as we've seen, although all by itself it prints out true, when compared with the comparison operator, that is not going to happen. Control Z, put the code back, and we can see how that worked. Okay, now what happens if I put in true? What will this one do? Comment, uncomment. This evaluates the true. This evaluates the true. What will occur? And one other thing I want to try. Print type. What happens when we evaluate this as a statement? What will occur? Control /. Let's run it. It comes out as a Boolean value. So we are comparing two Boolean values when we say, is this Boolean true, with the value of true, the equal of this expression's result, which is a Boolean value of true, and that's why it resolves that way. Another interesting option that shows up in a number of languages, like most languages, is this concept of none or null. Now, it really depends on which language you're using. Like if I'm using the database programming language of SQL, we use the word null. But other languages, like Python, uses the word none. And it means that we don't know what a value is, or it means that there's nothing there. That one's tricky, because sometimes it means that nothing is there, and other times it means that there's something there, we just don't know what the value is. And academically, you can get into these arguments about what null or none really means. But for us, it's not all that important. What we care about is, how does it work? How can you use it? And let's take a look. So I'm going to go ahead and set up a variable called none, and I'm going to ask the question. What does none evaluate into? Does it evaluate as true or false? And we find out that when you have none, it evaluates as false. So this is interesting. This is not a string, it's the word none, indicating that if nothing is there, then it's not considered to be a true value. It's considered to be a false value. We'll see more of this in context later on in the course. This one here is can be difficult to wrap your brain around at first, so you need some context before it really makes sense. Loops. Loops are something that are very useful. They allow you to perform an action repeatedly until you tell it to stop. Or in some cases, depending on the type of loop, it'll stop automatically. The most classic loop you're going to deal with is something called a while loop. While something is true, I want you to continue performing some actions. The syntax for it looks like this. Set up a counter, some kind of variable as acts as a counter, and ask a question. Is it true that the counter is currently set to a value less than 3? Since 0 is less than 3, it will perform the action. Print out the counter. It'll print out 0. Then I'm going to take the counter, add 1 to it, and set the counter variable to counter plus 1, which would be 0 plus 1, 1. It'll ask the question again by looping to the top of the while statement, asking the question, is 1 less than 3? That is true. It'll add 1, print it out, add 1 to it, that'll be 2. Is 2 less than 3? That's also true. Prints out 2. Bumps it up to 3. Is 3 less than 3? That is not true. And as such, it doesn't go any further. It stops looping at that point. And we can see that behavior if we just paste this in and run it. 0, 1, and 2. So the big trick here is a counter. Now people will use, like I as a counter. That's a very common thing to see. And there's nothing wrong with that per se. I just think that making things a bit more explicit in class is easier to follow. But if you ever see something like this, this is kind of the classic abbreviation for the pseudocode that would look like, or how people would use this. You can also do something called setting a flag. The flag is something that you switch either on or off, and then based on what you've set it onto, you tell the program to perform some kind of action. In this case, the action is if the flag is equal to 0, I don't want to continue the loop. But if it's not equal to 0, I want you to continue looping. So while it's true that this variable string user input is not equal to 0, print out the name and then ask the question again. Type in a string to echo. Enter 0 to quit. As soon as they type in 0, this will become 0, and it will no longer be true that 0 is not equal to 0. Now, note, this one does not have quotes. And since I'm using input, it's actually coming in as a string. So this string of 0 is not equal to that string of 0. If this ever evaluates to false, it would not continue to loop. And we can see it in action here. So when I first type in something, it echoes that out and asks the same question. I type in something else. Echoes it out and asks the same question. Okay, I'll go ahead and put in a 0 this time, hit enter, and it stops looping. So this is a convenient way to flag when you're done with the loop and just continue on with the rest of your program. Two nice additions to your while loop are the break and continue statements. Let's take a look at what they do. So I'm going to go ahead and take the code out of this example, put it over here in my test file, and we'll just test it out. So the code reads, make a variable called string user input. And while it's true, while something is true, ask for some input. So the input is some string to echo back to the user. Now note I'm asking them to enter 0 to quit. That's kind of a key feature here. The idea is that if they enter in 0, I will break out of the loop, and I'll do so by examining the content of that string I get back from input. And if it matches a 0, and remember that an input statement always returns a string, so I'll use quotes there. It's not an integer I'm comparing, it's a string with 0 in it. I will break out that loop. Otherwise, I'll just print whatever they typed in. So let's see it in action. So if I type in something else, it echoes that out. If I type in something different, it echoes that out, and so on. Until comes the time I type in 0. And as soon as I type in 0, it's out. So this, of course, could be typed in like this. It's complaining right now with these little gray underlines because it wants me to put things on separate lines. Also, it doesn't like the parentheses. And if you turn your homework in that way, that's fine with me, as long as your code works. I don't find that, I find it a little bit easier to read with the parentheses myself, but maybe that's because I've been doing it for so many years that way. But that's it. So break causes it to break out of the loop. And it's an important thing to know because we use it for things like building a menu. I'll show you something like that in just a bit. Another one is continue. Well, look at this. Let's look at this example. Okay, so same variable. I start off with that. While something is true, get the input, and if they type in 0, break. If they type in C, continue. Now what continue does is it does not proceed down to the next line of code, which in this case would be line 6. So let me run this. I'll put in something. That gets echoed. If I put in C though, I don't see, oh, that's lowercase c. I should be careful of that. Let's try uppercase C. Notice that it never prints out the uppercase C. That's because as soon as it hits continue, it jumps back up to line 2 and continues running the loop. Now this loop will always continue by itself once it hits the last statement in the loop. But if you would like to have it continue before it hits the last statement in the loop, you can use continue to do it. That way it conditionally will return to the top. Break conditionally returns to the bottom. By condition, I mean that you normally would set up a condition. Tell you the truth, if you just have break in there without any conditional logic, it will just break without, it'll never get any further than line 4 because it'll always break out of it. Now in other languages, instead of using break, you may see the word return. Return is another word that they use to stop running something and return out. But break is probably certainly the most common one I've seen. As I've said, one simple use of break or continue is to create a menu that allows the user to make choices, and then you make decisions in your code based on the choices of the user. That way the program can be written once but used many different ways. Let's take a look at a simple example in this lab. So once again, I expect you to go ahead and pause it, type this out, and test the code, see what it does. And then when you're done with that, write down what it does, describe it as if you were talking to a coworker and describing the program. Once you're done with that, we'll come right back. Okay, so we're going to go over here and make a new file, new Python file. It's going to be lab 3-3. Or paste that code in because you guys do not need to watch me type. As I've mentioned many times, it's pretty ugly. So what does this do? Well, first of all, let's make sure it runs. Add data, delete data. Okay, so 1 is add data, 2 is delete data, and it pauses and waits for your input. Now notice that it also has an additional instruction. In this case, it says enter 0 to quit. Now if I go ahead and enter in 1, it says adding. But it comes back and shows me the same menu. If I enter in 2, it says deleting. And if I enter in 0, it finishes out. Now there's a couple things that hopefully you noted. That right now all it's doing is printing something out, but we would add code later on to perform some kind of action, such as printing it out to the user, or maybe saving the data to a text file, or maybe both. Sometimes you will collect data and then want to delete it after the fact, so you could put in code that would delete it out of a text file. There'd be lots of choices, but right now what we're doing is we're stubbing out the code. What this means is stubbing out is just where you put in some placeholder. It's not the actual code you're going to use, it's just a placeholder that is going to stay there until you get around to putting in the real code. So we just stubbed this out. And another thing I noticed is that when it prints out, it doesn't look that pleasant, so I might actually go ahead and put in extra spaces. So this would indent. I could put in a tab if I thought that would look nicer. I could put in both. I also probably want to go ahead and put in spaces like this so that it's easier to see where you type. As I'm working with code like this, it's really important that I keep examining how it's going to look to the end user and then keep testing it. So I think that looks a little bit better. We'll go ahead and type it out. I don't like the way this, the entry point is kind of showing up. I'm not really typing in there, I'm typing out here. Also, I try things like putting in numbers that are not part of the menu option. What does it do at that point? Well, at that point, since it doesn't match any of the choices, it doesn't do anything, it just repeats. perhaps what I need to do is put in an else statement that says print please choose only 1, 2, or 0. Something like that. And if I don't want it pushed right up against the side of the console window, sometimes you might want to put a space in there. Anyway, that's kind of all the things you would do with this. Oops, forgot the colon. That's kind of all the things that you would do with this lab. And hopefully you had some fun in that. And understood what the code was doing. An important thing to do with the data that you collect from the user is to save it. Remember that when your program stops running, the data that you captured from the user just disappears unless you've saved it someplace. One of the most common places to save data is in a file, typically a text file, but it can be something else like a fancy database file. Let's start with a simple text file in this course. So to create a new file or to use an existing file, you can use Python's open function. When you do, you give it the name of the file that you want to use and what type of activity you would like to perform once the file is open. The three main options are you can write, you can append, or you can read. If you use write, whatever's in the file will be erased and new data will be put in there. If you use append, whatever data is in there is maintained, but new data is added. And of course, if you use read, you collect data from that file and you put it in memory so your program can access it. In this example, we'll just use the A option to make it append. I've copied the code and put it in PyCharm. So we're going to go ahead and run it. First of all, let me get rid of the file there. So the file does not exist in there as of yet, testdata.txt, but it's going to in just a second. Put in some fake data, and there we go. Now, if I run it again, more data will be added. And it will keep adding data since it's in append mode. If we have a W there, it would override the data. And all I see is the most recent entry. So pretty simple to make Python open up a file, and then to write the data into the file, you just use the write command. This function will force the data to be written. Notice that if I want there to be a carriage return, I'll put it in there, a new line there, escape there. And then I need to close the connection to that file with the close function. The close function can optionally be put in or not, but it's a real good idea to get into practice of doing so. If you don't put that in there, the program will still run. It's just sloppy coding. So as you can see, it's easy to write to a file. Let's look at another example here. Copy this out. And then I'm going to paste it into PyCharm. Clear this out down here, and we'll give it a try. Now what this is going to do is it's going to do the append just like before, but it's also going to print out a little message to the user to type in a string to write and enter exit, the word exit, if you want to quit. I think I'll make that a little bit nicer. Let's see here. And I have my while loop. I capture the data, the input from the user, and then if it matches the word exit, and remember that The user could type it in all caps, they could type it in all lowercase, they could type it in mixed case. So you might want to use the lower function to verify what the user is typing, or not verify, make it so that whatever the user typed in is acceptable, uppercase, lowercase, any combination. That's a good thing to do when you're asking the user for data like this. And then if they type in the word exit, break. So let me go ahead and run it. Enter in data, enter in more data, enter in more data. And then finally I type in the word exit. If I type in all uppercase, I don't know why I would, but let's say I did, you can see it still works. And once again, I can go back to that file and see that our new data has indeed been appended. Now here's an important tip that you might find useful, especially on a Mac. On a Mac, you don't really have you don't typically use the drive letter to identify where your data is going to go. So instead, what you can do is you can just put in the name of the file. Now when I do this, watch what happens. Just to make sure it looks different. Exit. Okay. Where the file was saved is not the same place. It was no longer saved at this location. You can see that in this case there is no D. There's also no 4Bs. Where it was saved is actually in the same location as this file. If I right click on this in PyCharm and tell it to open or show in Explorer, you'll find that the file that you're saving the data to, when you just put the name, will be right next to wherever the script is. That's a really good thing to do. So it's well, at least in a classroom anyway, because that way you know exactly where the file is going to be and it's relative to your script file, so it's easier for you to find and turn in for your homework. Anyway, that's a tip I think you'll find useful. Let's try it out yourself by going over and trying this lab out. We're going to use very similar code to add two numbers together and give back the sum. We're going to store the numbers and the sum in a text file, and then let the user add more numbers and get a sum, and then store that as well until the user types and quit. Very useful little program. It's useful because it's going to be very similar to the homework assignment. So why don't you go ahead and pause the video and see if you can get this to work. Let's take a look at my example of how to solve this lab. Now, do keep in mind that the way you solve this lab, it could be very different. As long as it works, that'll be fine. So first thing I do is I basically copy the previous code. And then start modifying it. One of the modifications was putting in a print statement that tells the user I want them to type in two numbers to add together and enter exit to quit. Notice that this is outside of the while loop, so it'll only print out once. Then I ask them for the first number and the second number. I check to see whether or not either number had the word exit in it. It should not, but remember that this always returns a string. And tell you the truth, that's okay for our purposes. When we do find the word exit in either one of those, because I'm using the or, I will break out of the loop and then close the file. Otherwise, I'm going to convert those strings into floating point values, capture the sum, build a string for presentation purposes of the first number plus the second number equals the sum, print that to the user and write it to the file with a carriage return, add it in the file, and tell the user the data was saved. Let's see if it works. So let's see. Get rid of that file. Thank you. preview, just do it. Okay, do refactoring. Okay, let's run it. Enter first number, 2. Enter next number, 5. 2 plus 5 is 7. So a couple things we could do. It looks like it worked. Did the file appear? Enter the first number. Nope, we haven't done the second one here. Let's go ahead and say, let's see, how about 4 and 6? Excellent. Data saved. Okay, now we type in exit, and oops, looks like exit has to be demanded again because of the way the logic is put together. You could actually put a different number in here, like anything like that. But although it runs, it's a little rocky. It could be cleaned up. I did actually capture the data I wanted. That looks fine with me, so the output's all right. But there are a few things I don't like. First of all, the instructions don't show up multiple times as far as what we want the user to do. So I think I might move this down into here. I think that'll be a better choice. I didn't like the fact that once I typed in exit, I had to continue typing something in. So if that's the case, what I want to do is I want to come over here and change this. So I'm going to go ahead and put that up there and say break, oops, colon, break. After if they've typed in exit. And I'll do the same down here. If there's lowercase breakout. So I think that's going to be a little bit better. Now, the else will be part of the second if, but to tell you the truth, that's perfectly fine. In fact, in this case, if they didn't break out of it, I guess I really want to do it anyway, so I can take out the else. Now I want to take out all these extra spaces here. So what I'm going to do is I'm going to hold down the Alt key. I'm going to left click and oops, Control and Alt key. Let's see if I get this right. There we go. Control, Alt, and drag. Yeah, I know that combination's there. Okay, well, I'll have to look it up. Okay, just take it out manually. There's a combination you can use to highlight just a section of it and then go vertical, and that is convenient to remove a bunch of things. I'm not sure what it is right now. Can't remember. So what I'm going to do is I'm going to try it out like this and see if it works better. First number, second number, shows what it did, says it's saved, and now we see the instructions again. Another number, saved again. And I'll type in exit this time. And it doesn't annoy me by going through and asking me the same question twice. And that's it. So I think that would be pretty good. I'd probably tweak it a little bit more to make it nicer, but that's the way I kind of handle it. And when you go through and do assignment 3, think about how you can improve your code a little bit, test it this way, and also think about how we did the loop in the menu. It's a really handy thing to do in programming. Next, I want to talk about some advanced features. The first one is called a list. A list allows me to collect a set of values into a single variable. So here's the variable I have. I put in a prefix of LST for list data equals square brackets and then multiple values, red, green, and blue, 1, 2, or 3, whatever you want to put in there. It doesn't really matter. With a list, it'll accept pretty much anything that will be acceptable within the square brackets. Now to put the data in the list is easy. To get it back out, it's not that difficult either. You just have to use a numeric value to indicate which item you want. And the numbering system starts off at 0, which is confusing to people at first. So red is actually value 0, green value 1, and blue value 2. As long as you remember that it starts off with 0, it's pretty easy to figure out what you're getting. Do be aware that there are some languages out there that have a numbering system that starts at 1 instead of 0. But those are very rare. So you can assume, and be right almost always, that the numbering system will start at 0. We will talk more about lists in the 4th and 5th module. But the second feature, advanced feature I'd like to talk about is something called program arguments. Now, program arguments are a very handy feature because it allows you to have your script perform different actions based on user input when the script is started. What we just saw is a user input being added while the script was running. So while the script was running, the user could choose items from a menu and control the way the program ran. But what if there's no user sitting at the keyboard? What if you're using your Python script for automation? What I mean by that is at night or sometimes where there's no human around, maybe it's not available, or maybe you just want it to be separate from human interaction. You can have your program perform some kind of task. And if you'd like to make your program more flexible in a way that it can perform tasks differently, maybe similar tasks, but maybe slightly different from each other, you can use these programming arguments to do it. The way it works is you submit an argument and the program performs something different. Let me show you what I mean. So if I go to a command window and I type in Python, it enters into interactive mode, and I can type in code interactively. And perform an action, type in exit to exit, and oops, exit with parentheses, and we're out. But I can alter the way that program behaves by typing in an argument. Now, if I put a question mark, it's not going to accept it. If I put a combination of a slash and a question mark, now I can see I get a very different outcome. Now I'm actually seeing help information about the choices there are. You'll notice that these choices, like B, uppercase and lowercase b, have a dash in front of them. Instead of a slash, I could use a dash. And that's been an industry standard for a very long time. So slash and the dash are interchangeable, at least in most cases. And you can see that there's a lot of options that you can send to the Python program to modify the way it's going to behave. Now, when you want to make your own script, you can allow arguments to be passed into your script, examine what the arguments are, and then based on what was passed in, you can determine how it's going to run. So best thing to do is just kind of show you an example. So what we've been doing is pausing the program, waiting for the user to enter in something, and then when they do, we respond. That waits for the user input. Now we're going to allow the user to input an argument, an option, when the script starts up. And to do that, we're going to import some additional code. This additional code is found in a module called System, or sys. Now, modules are just another file with Python code in it, but that code is usually written by somebody else. Later in the course, you will write your own modules and add them to an existing another script. So you'll take and write multiple script files and connect them as modules. But that's later on down the road. For right now, we're just going to import a module that was written by somebody else, the system module. And once, this actually should be in green. There's always something. Once we do that, we will have access to a collection of data, a list called argument values. So argument values is spelled ARGV but this is going to be a list, just like that list we saw that we a few seconds ago or a few minutes ago. And we can use 0, 1, 2, 3, 4 index values, number values, to extract pieces of data from that list. So for example, if I look here, if I start up a argument demo py file and I pass in my input, the first value, not the 0th value, but the first value will be the input that I passed in. Now, you may be wondering what the 0th value is. The 0th value is the name of the file, name and path of the file. So 0 is a script name. If you're running on a PC, it'll also be the path. On a Mac, it'll just be the script name. 1 will be the first argument, 2 will be the second argument, and so on. It'll keep going like that. So if I take this code and I bring it over to PyCharm, yep, come on. And I run it, it says index out of range. But, let me come back over to a command shell and type in Python, quote, let's get the name of this file, copy path, it still says it, but let me type in an argument. It does as well. But notice that this time it says get argument 2's out of range. Okay, let's try it again. Space, how about some Z's? And this time it worked. When I told it to print out argument 0, it printed out the file and the path. Again, I'm running on a PC. Argument 1 and argument 2 with these values. You can see that it picked it up from my entries here, my arguments being passed into the script. Now, in most cases, you will see things like a dash and an option. And then the programmer checks to see whether or not somebody typed in a dash or a dash A or dash Z and perform some kind of action based on that. It can use the location of the file to determine where it wants to store data or do other things with it. And that's handy too. But the key things with arguments are that they're customizable. You can pass in various set of options. Notice that there's no comma in between, which is kind of interesting. It's a space. This is very old school, so I wouldn't put a comma in there and expect it to work as I might expect it. It's actually the space that separates it. And notice that I'm examining the combination of dash A or dash Z to see what I get. Let's look at another example. So in this example, I'm examining whether or not we've got more than 2 argument values. The length function will tell me that. When you use the length function on a collection of data, like a list, it will tell you how many items are in there. That's the length of the items. So if there's more than 2, I know I can actually go through and get 0, 1, and 2. And that's what I'm going to do. I'm going to go ahead and take this code and copy it and paste it into PyCharm. And then once it's in there, I can try and test it. So let me go ahead and do that now. And you can see that it actually worked, but what it did was print out, this script requires 2 arguments to run. My script, argument 1 and argument 2 is the example. Now, what people would normally do would not be to use PyCharm to run the code. Normally, they would run the code from a command shell. Let's go over and try it from there. So I'm going to type in Python, quote, this file name, copy path, paste it, close the quote, and you can see I get the same message. But now let me add some arguments. The arguments I'm adding are some numbers, 3 and 4, which totals to the sum of 7. So you can see that when we pass in the arguments, it works just fine, because the logic says pick up the value for argument 1, the value for argument 2, add them together. And that's what you get. And if you can't find at least more than 2 arguments in the argument value collection, just go ahead and print out this message. Now, if I want to test this out in PyCharm, I can do so as well. If I go up to the Run button, there are menu option. There is a configuration feature, Edit Configurations, and you can use parameters here. Parameters and arguments are commonly terms that get interchanged. Parameters are what receive the arguments, and arguments are passed into parameters. But don't worry about that. This is an argument that we're going to pass in. I'm going to pass in 5 and 8 with a space in between. I'll say apply. Now when I run this, it will get the arguments. You can see that it added 5 and 8. I no longer get that message. So the people that made PyCharm knew that this was a feature that would be useful, because using these arguments is a feature that is useful. And so they made sure that that configuration option was there. So common question I get is, why use arguments? Well, arguments are really handy when you're setting up automation. And as I said, you don't have to have user interaction other than when you first create the code to run or automate the script. So for example, let's say that I have created a Python script called check for new log file.py. And maybe the script does something like, if it finds a new log file, you can either have it override the log file or not. And if you pass in there with override, it will go ahead and overwrite that file so that it starts off fresh. If you don't do that, it would just check to see if it was there and maybe return true or some other statement that would say, yes, we found the log file. So I could take code like that and put it in one of those batch files that we talked about early on. So if I made a little batch file, and let's see, this is code that will work. Let me save it. And I think I'll put it on my desktop. I'll put quotes around it so it doesn't save it with a txt extension for me. Test batch.eat. And now, when I run that batch file, it'll run that code. Now, you may not have seen it because it flashed. It flashed on the screen and then it disappeared. I know this because if, let's say I don't pass any arguments in at all. Oops, I gotta save it. Oops, I guess that's not gonna help either. So let me modify the code here. And we'll put an input command to pause it. Okay. See how it paused? So it was happening so fast you couldn't see it. Yep, now save it. So now we can see the answer. Now, if in real life, I wouldn't have this much interaction. Basically, I would set this to whatever values I wanted, and that would pretty much be it. It'd stay that way until I need to change some kind of configuration. Also, I wouldn't expect the user to be sitting there waiting to read the message. I would do something like have it write that message or that data to a file like we did in the lab. But once I had that tested, I would open up something like a task scheduler and schedule that Python script or the batch file or some other mechanism to run at a given time. And then that file would take off and run on that particular time frame, or when I double clicked on it and forced it to run automatically. So this is a great thing to get used to using in the future. Again, it's kind of an advanced feature when you want to set up automation. A lot of people take the course so they can learn how to set up automation like in a test lab or other development tasks. So eventually you want to start playing around with this. But for now, that's kind of as far as we need to get. So we looked at common statements, expressions, and features of the language that included things like pseudocode, conditional statements, multiple conditional expressions, comparison operators, the Boolean values and how they, what the relationship is to integers number 1, 0, and 2, or anything non-1 and non-0. We looked at loops a little bit closer. We talked about the break and continue commands, and we talked about how you can write data to a file, and also how you can pass arguments into a script. Try to focus on understanding how to, try to focus on being able to answer these questions like to a coworker or in an interview. Once you can answer these questions from memory, and of course when you're learning, just scroll up and down and look for the answers. Once you can answer these questions from memory, you're ready to go. You're ready to move on, do the assignment, and move on to the next module. And I will see you there.